So let's convert 200 degrees to radians, and conversely, let's go from 2 radians to degrees. So the basic idea is to work out what proportion of a full circle you're dealing with. So what proportion of a full circle is 200 degrees? Well, 200 divided by 360. That's the fraction of a full circle. And what's a full circle in radians? A full circle in radians is 2 pi. So it would be this fraction of 2 pi. So this is equal to 200 degrees in radians. Nice and simple. On the other hand, 2 radians going to degrees. 2 radians, what proportion of a full circle is that? Well, this one's a little bit weird because I'm sure you're very used to seeing radians with pi's in them. The only reason there's a pi in radians frequently is because a full circle is 2 pi, and you're often cutting a full circle into kind of a reasonable number of pieces, like 3 or 4 or 5 or 6 or something. But you don't need to do that, right? There's no need. You could divide a circle in ridiculously silly proportions. So 2 radians is a completely reasonable measure. All it represents is the angle where the length around the outside of or the arc length around the outside of the unit circle is just 2, not 2 pi, just 2, the number 2. So we need to work out what proportion of a full circle this is. So this is going to be 2 divided by 2 pi. That's the proportion of the full circle given by 2 radians. But then we've got to write it in degrees, so we'd have to multiply this by 360. This is equal to 2 radians in degrees. Okay, so both of these are kind of the fraction of the full circle. That's what I'm doing with each of these. So I'm doing these from first principles rather than using my my simple scale factors. I'm just doing it from first principles. So this is proportion, so fraction of the whole circle. Very nice.